Okay, guys, I wanted to graph one of these before we get started or before we go do some of the homework problems. And for this one, let's start with identifying all of the different parts. We could identify them as the letters that they are in our problem. We could think of A, H, and K. So in this case, A is whatever we're multiplying to our function. So our normal function is going to be the square root of X. Everything else are things that we're adding to it. So A in this case is whatever we're multiplying on the outside of that function. That's 3. Then H is whatever we're inputting or something that's affecting our input. In this case, it's 4, well, positive 4, but it's always going to be the opposite of whatever we have inside of our function. So what is going to bring this part back to 0? And in our case, it's going to be a -4. So -4, we're shifting left 4 units. And lastly, we just grab K. It's kind of like our afterthought. That's going to be -2. We have that. The next thing we want to worry about is our domain, especially in this case, because we have this function here. The square root of our function, whatever number we have on the inside cannot be negative. So what we'll do is say that our domain here is going to be all values of x plus 4 greater than or equal to 0. So all the positive values here. So let's see what our domain is. So here we have x is greater than or equal to 4. So let's kind of come over here and see what values we're going to input into our function. So here we have 1, 2, 3, 4. So -4. And this should actually be negative here. So it looks like all the values here, we're not going to have anything, any part of our graph here to the left of -4 or x equals -4. So we could ignore that part and pick values to the right of that number. So our domain from -4 to infinity, let's kind of make this look a little bit better. So from -4 to infinity, perfect. And we could figure out our range once we actually start this. But from here, if you do get confused at all you have to do is start finding numbers to plug in. And here we could start with our most left value, which is -4. So that's going to be our values of our input and our output. So we could pick a couple of values here. So starting off with -4, we could plug it into our function and see what we end up getting. So f of -4 is equal to 3 times the square root of -4 plus 4. And on the outside, -2. So we have 3 times the square root of -4 plus 4 is 0, -2. Square root of 0 is 0 times 3. This whole part ends up being 0. So our output is -2. So -2. We come down here to -1, -2. And that's our very first point. And notice that our parent function is going to be from here. Our parent function, not parent function, our toolkit function. F of x is equal to the square root of x. So when we input 0, we get 0. When we input 1, we get 1. When we input 4, because we want like nicer numbers, 1, 2, 3, 4, we get 2. And this is going to be our regular function. And let's see what happened to this point here. We moved it left 4 units. So 1, 2, 3, 4. We moved it down 2 units, 1, 2. And that's exactly what happened to this point here. We shifted it this way. The rest of the graph is going to be multiplied by that 3, which is going to shift it. It's going to stretch it vertically. So stretching it vertically is going to have it take off a lot faster. But let's see what other numbers we could find. So we want this inside to be the square root of 0 we did. Next one is going to be, next easy number is going to be the square root of 1. So I'm going to say -3. So that way when we input it, we end up with a nice number. So f of -3 is equal to 3 times the square root of -3 plus 4 minus 2. What I really wanted is to have a nice even root so we don't have to plug it into our calculator. So 3 times the square root, -3 plus 4 gives us +1. The square root of +1 is just going to be 1. So we have 3 times 1 minus 2. That's 3 minus 2, which is just 1. So over here, when we input -3, we get 1. So we input 1, 2, 3, we get +1. So up here, and the next nice root. So like the square root of 0 gives us 0. The square root of 1 gives us 1. The square root of 4 gives us 2. So this is going to be the next nice number that we want to put in. So square root of 4. In order to get a 4 on the inside over here, we can make this equal 0. So 0, 4, that gives us a nice number. So 0. Now we have f of 0, and that's 3 times the square root of our input plus 4, and then minus 2 on the outside. 3 times the square root of 4 minus 2. 3 times the square root of 4 is 2. And then minus 2. 3 times 2 is 6. Then minus 2. And 6 minus 2 is 4. So when we input 0, our output is 4. So when we input 0, our output is 1, 2, 3, 4. So 1, 2, 3, 4. And from here, we could kind of draw the rest of it based on this. Notice that if we shifted this up, well, actually up here, it appears as if, and then we shift it back here, it appears that all of our values tripled in size. So it makes sense that this is what our graph looks like, but our only graph is going to be this part right here. This is just part of our toolkit to kind of help us identify what the domain and range is. And that's it. If you have any questions, and if you do pick a value that just isn't the greatest, let me kind of show you how to do that part too. So 1 is not going to give us a nice solution. Let's see what 1 does. F of 1 is equal to 3 times the square root of our input plus 4, and then minus 2 on the outside here. 3 square root of 5, which doesn't have a nice root, minus 2. Let's get our calculator and see what that value is so that way we could plug it in. So we have 3 times the square root of 5. Square root is going to be second x squared for our square root part. 5 and exit out of the square root, minus 2. And there we go. We have approximately 4.7. So 4.7 coming over here. If this is 4, this is 5. 4.7 is going to be about here-ish, and that's exactly what we ended up with over here. So we input 1 and our output was approximately 4.7. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.